You know, it is a very specific, almost universal modern reflex.
Oh, definitely.
Like you wake up, you grab your phone off the nightstand, and you immediately check your weather app.
Right, just to see if you need an umbrella or, maybe a lighter jacket for the day.
Exactly. We all do it.
Yeah.
But when we do that, we are really just looking at this tiny, isolated pinpoint of data.
Yeah, a single pixel on a massive screen.
Right. We're looking at our own street, our own zip code, our own immediate comfort. And very rarely do we actually, zoom out to look at the entire map at once,
Which is, it's a profound oversight when you think about it.
Yeah, totally.
Because we tend to treat weather like it is this localized event happening just to us, isolated completely within our county lines.
Like we're in a bubble.
Exactly. It's binary in our heads. It's raining or it's not raining, it's hot or it's cold. But the atmosphere, it just doesn't care about city limits.
No, it really doesn't.
It is a massive interconnected fluid dynamic system. So a pressure shift in one time zone is actually the direct physical catalyst for a storm in another.
And that is exactly our mission for today.
Yeah.
Because today's Deep Dive is all about understanding the U.S. weather map for August 10th, 2026.
Which is quite a map to look at today.
It really is. And we want to look at it not just as a random list of local temperatures that dictate your morning commute, but as this interconnected web of atmospheric dominoes.
Right, seeing the whole continental engine at work.
We're talking about how heat domes, pressure ridges, and coastal contrasts dictate absolutely everything, from aviation delays to actual literal public health emergencies.
And, it is a perfect day to analyze, too, because traditionally, August is viewed as the absolute peak of summer stagnation.
Right, the dog days.
Right, so the dog days where the air just sits there and bakes. But when you look at today's data, it is not stagnant at all. It's really a dynamic, almost violent battleground.
It's all moving.
Yeah, you have this extreme saturated moisture dominating the east, and then severe fire-fueling desiccation out west.
Just totally dried out.
Right. And the tension between those two extremes is what's driving the entire continental pattern today.
Okay, let's unpack this because we are pulling from a fantastic compilation of August 10 reports from the Daily Tech Reader today.
They do great work aggregating this stuff.
They really do. They've pulled together the latest data from the NOAA, the National Weather Service, the National Hurricane Center, and AccuWeather.
All the heavy hitters.
Exactly. So we need to start in the east, where the atmosphere right now isn't just hot, it is physically heavy.
That's a good way to put it.
I'm looking at the I-95 corridor data,
Mm-hmm.
what the forecasters just keep using over and over is oppressive.
And I gotta say, oppressive is mathematically the right word here. Because if you look at New York City and Newark today, they are sitting at 89 degrees Fahrenheit.
Which, on paper, doesn't sound catastrophic for August.
Right, it sounds pretty standard. But that number is totally deceiving. They are carrying over this muggy, completely saturated air from Sunday with absolutely zero overnight recovery.
Wow, zero recovery.
Yeah. And part of the reason for this specific setup today is a wave of shortwave energy that's pushing offshore from New York and Boston.
Okay, wait, let's define that real quick for everyone listening. Shortwave energy is essentially a ripple in the atmospheric flow, right? Like a kink in the upper level winds.
That's exactly it. Think of it like a pebble dropped in a fast-moving stream. That shortwave energy moving offshore creates a temporary vacuum behind it.
Oh, I see.
And that vacuum allows this incredibly dense, humid air to just sit and bake over the Northeast while they wait for the next system to build.
So they're just stuck in the soup.
Stuck in the soup. So Washington, D.C. is hitting 91 degrees today, but the dew points are lingering in the thick, low 70s.
Which feels like wearing an invisible thermal blanket. It's just awful.
It really is.
And as you transition south on the map, you see high pressure reasserting itself. Charlotte and Raleigh are in the mid-upper 80s, which actually aligns perfectly with NOAA's August outlook for the Carolinas.
Right, they predicted a warm but drying lean for that region.
Exactly. But then you hit Florida and the Gulf Coast, and that invisible thermal blanket suddenly becomes this heavy, wet quilt.
A very wet quilt.
Miami is holding at 90 degrees with its daily sea breeze convection cycle. Orlando is at 92, and Tampa's at 91.
And those Florida numbers, they are driven by the sheer thermal mass of the Gulf of Mexico right now.
Because the water is so hot.
Exactly. The Gulf acts like a massive bath of latent heat. It is just evaporating millions of gallons of water into the lower atmosphere every single hour.
Which brings up a really great point about the heat index. because, people always complain about it. They roll their eyes at the heat index as just sensationalized, quote-unquote, feels like media hype.
Oh, I hear that all the time.
Right. But biologically speaking, the National Weather Service is treating today's heat index in Houston, where it's 97 degrees, but feeling like 105, as a much greater threat than a higher ambient temperature in Nevada.
Yes, and they are absolutely right to do so.
So walk us through the thermodynamics of that. Why does human biology actually break down faster at 97 Gulf degrees than 105 desert degrees?
Well, that distinction is really the difference between simple discomfort and actual medical peril.
Okay, how so?
So a thermometer just measures the ambient kinetic energy in the air, just pure temperature, but the heat index measures thermodynamics, specifically the air's capacity to absorb moisture.
Because of sweat, right?
Exactly. The human body's primary cooling mechanism is the evaporation of sweat. When sweat turns from a liquid into a gas, it literally pulls heat away from your skin.
Right, it's an incredibly efficient biological air conditioner.
Normally, yes.
Yeah.
But when you have Gulf moisture completely saturating the air, like in Houston today, the atmosphere is already full of water vapor. It simply cannot accept anymore.
So the air is effectively full.
Full to the brim. That stall in evaporation is what the National Weather Service is actually measuring when they issue those heat warnings.
Wow. So the sweat just sits there.
Yeah, it pools on your skin.
Mm-hmm.
The evaporation process completely flatlines. And when evaporation stalls, your body's internal engine has absolutely no way to vent its excess heat.
So you just keep getting hotter.
Exactly. The core temperature begins to rise. That is why a 97-degree day in Houston with high humidity triggers a biological override. Your cooling system has been forcibly shut off by the moisture in the atmosphere.
That is terrifying when you frame it as an environmental override of our biology.
It is a serious medical emergency waiting to happen.
And this moisture engine doesn't seem to be slowing down at all, does it?
Not at all.
Okay.
I mean, if we look out over the Atlantic right now, the National Hurricane Center is currently monitoring a tropical wave several hundred miles west-southwest of the Cabo Verde Islands.
Is that a threat to the coast?
Well, it currently has a medium development chance over the next 7 days, but there is no immediate threat to Florida expected from it.
Okay, that's good news at least.
Definitely. But it proves the scale of the moisture engine we are dealing with. What's fascinating here is how the Atlantic high pressure building northward actually dictates the micro-level daily weather in Florida.
How does it do that?
It physically suppresses the morning storms. It pushes all that atmospheric energy down like coiled spring.
Oh, I see.
And it holds it there only to fuel explosive, isolated inland thunderstorm cells by the mid-afternoon.
So the atmosphere is just storing up all this energy and then releasing it all at once when the temperature peaks.
Exactly. It's a daily cycle of suppression and explosion.
Wow. Now, because this massive moisture engine in the east is shifting the broader continental jet stream, it is physically forcing a completely different reality to anchor itself over the west.
A starkly different reality.
Yeah, we are moving into the scorching core of the country now. We are talking about the Western Heat Dome.
This is the perfect example of atmospheric cause and effect. The systems in the east push the upper-level winds into a massive, stubborn ridge over the western interior.
So what exactly is a heat dome, structurally speaking?
Well, a heat dome is essentially a giant atmospheric lid of high pressure. And because it is high pressure, the air is actively sinking.
Okay.
In meteorology, we call this subsidence. As the air sinks, it compresses under its own weight, and as it compresses, it heats up and dries out.
It's like using a bicycle pump. Like as you compress the air into the tire, the barrel of the pump gets physically hot in your hands.
That is the exact thermodynamic mechanism happening over half the continent right now. That sinking, compressing motion physically prevents clouds from developing.
So it just bakes everything beneath it.
Right. It destroys any chance of moisture or shade.
Which totally explains the grim reality for Texas right now. Because Texas is totally locked in under this lid.
It's completely stalled over them.
Dallas and Fort Worth are at 100 degrees with a heat index of 100 to 105, and it is entirely rain-free. Austin hits 101.
And those are just the edges of the extreme heat.
Yeah, because then you push into the desert Southwest, and the numbers become genuinely staggering.
They really do.
Las Vegas is at 112 degrees under an active extreme heat warning. Yuma and Palm Springs are hitting 113.
Incredible.
And Lake Havasu is pacing the entire nation at a severe 114 degrees today. Clark County has actually had to activate their emergency cooling stations and keep them open through Tuesday just to prevent mass casualties.
Which is completely necessary. But, the daytime highs capture the headlines naturally.
114 is a scary number.
Right. But the truly insidious part of a high-pressure heat dome isn't actually the afternoon peak. It is the complete failure of the nighttime environment.
Here's where it gets really interesting, folks. Because if you look at the data for Phoenix today, the daytime high is between 111 and 113 degrees.
Which is brutal.
Brutal, yeah. But the most dangerous statistic for Phoenix in this entire report is the overnight low. The temperature only falls into the low 90s at night.
That is the real killer.
I want you to imagine running a marathon, but you're only allowed to walk for 30 seconds before you have to start sprinting again.
That's a great analogy.
That is exactly what a 92-degree overnight low does to your body.
The marathon analogy maps perfectly to the physics of both human biology and city infrastructure.
Right.
Because the National Weather Service issues these severe warnings because of how rapidly heat exposure compounds in these exact conditions.
Because you never cool down.
Exactly. Your body never gets a chance to reset its thermal baseline, so you go from heat cramps, which feel like a minor nuisance, straight to heat exhaustion.
And then it escalates from there.
Rapidly. It goes right into heat stroke, which is a state where your central nervous system actually begins to misfire.
That is, wow. And it isn't just biology that's failing in these conditions, right?
Yeah.
It's the physical grid.
Yeah. The lack of a recovery window at night is the true silent danger. The infrastructure never cools down.
Because of concrete.
Concrete and asphalt have immense thermal mass. They absorb 113-degree heat all day and then just radiate it back out all night long.
Like an oven left on low.
Yes. And your power transformers, they don't get a chance to shed their operating heat. Air conditioners are running at maximum load 24 hours a day, drawing massive amounts of current.
Straining the whole system.
It puts the entire urban ecosystem under constant, unrelenting metabolic stress.
It is relentless. But, nature abhors a vacuum, and it also hates an imbalance. This massive, stagnant dome of dry heat doesn't just sit there peacefully.
Oh, no, it certainly doesn't.
Because when this extreme, dry, compressed heat meets shifting ocean currents and rugged topography, it creates violent, almost unbelievable microclimates.
That is the friction of the system. You have these continental-scale pressure systems grinding against highly localized geography.
And the starkest contrast in the entire nation today is happening in California. The Central Valley is absolutely baking under that subsidence we talked about earlier.
It's acting like a furnace.
Redding is facing extreme heat at 108 degrees. Fresno is at 106. Bakersfield is at 105. Sacramento is at 103.
All under that high-pressure lid.
Right. But then, less than 60 miles away on the coast, San Francisco is sitting at a cool 63 degrees under a thick marine layer.
Just a completely different world.
60 miles. That is a 45-degree difference in an hour's drive. I look at this data, and honestly, my brain breaks a little bit.
It's hard to wrap your head around.
Because thermodynamics says temperatures want to equalize, right? Like opening an industrial freezer door while standing next to a blast furnace, hot air should immediately rush toward the coast to fill that cold void.
Right. Naturally, it wants to mix.
But why is nature failing to equalize here?
Well, if we connect this to the bigger picture we've been painting, it all comes back to that high-pressure ridge acting as a physical dam.
Okay, a dam holding the air back.
Yeah. San Francisco sits right on the ocean, and the California current brings upwelling, incredibly cold water down the coast.
Okay.
That cold water chills the air immediately above it, creating a dense, cool, moist marine layer.
Like a heavy liquid sitting right on the beach.
Yes, exactly like a liquid. And normally, that cool, dense air might push inland to equalize the temperatures.
But it can't.
It can't, because that massive high-pressure lid over the interior is pushing down and outward. It traps that cold marine layer right against the coast, preventing it from moving east.
Oh, wow.
Meanwhile, just over the coastal mountain ranges, that same high pressure is compressing and superheating the air in the Central Valley.
So the mountains are basically the rim of a bowl.
Yes. The high pressure is forcing two completely different thermodynamic realities to exist side by side without ever mixing.
That is wild. And the consequence of that superheated dry air in the interior is devastating, right?
Right.
Because it's fire.
That is the inevitable result, unfortunately.
The Mountain West is facing a massive threat right now. Denver is at 99 degrees. Cheyenne is at 100. and Casper is hitting 101.
Extremely dangerous conditions for that elevation.
And they are all facing critical fire weather because you combine that low relative humidity from the sinking air with gusty afternoon winds.
It's the worst possible combination.
And the NWS is noting that grass fire risks in Texas are also set to increase significantly by mid to late week.
Yeah, because the vegetation in these areas has been completely baked by the heat dome.
Just dried to a crisp.
It turns millions of acres of forest, brush, and grassland into an absolute tinderbox. The moisture content in the fuel is virtually zero.
So it's just waiting for a spark.
Exactly. All it takes is one dry lightning strike, one dragged trailer chain on a highway, or one errant spark, and the wind just does the rest.
And we are seeing exactly that in the Pacific Northwest crisis right now. Portland is at 87 degrees dry with dangerous fire conditions.
Very tense situation up there.
Boise is at 92 degrees and sitting under active red flag warnings. And the devastation is already a reality in eastern Washington.
Yes, the old Trails fire.
Right. Near Spokane, which is sitting at 84 degrees today, you have this massive fire. The details are just heartbreaking. It has already destroyed hundreds of structures.
And it's moving fast.
It is threatening thousands of homes as we speak. The ambient smoke is hazardous, and Governor Bob Ferguson's public health emergency declaration remains in full effect.
It is a rapidly evolving, truly devastating situation on the ground. And, this is where we see the final, perhaps most profound piece of this continental engine.
How everything is connected.
Exactly. The fires burning in the Pacific Northwest do not stay in the Pacific Northwest.
Because the smoke travels.
Right. Because the atmosphere is a shared fluid medium, the consequences of a local fire are carried across the map to people who haven't seen a flame in months.
Which brings us to atmospheric transport, and specifically the rivers of smoke.
This is a very poetic, very real phenomenon.
This part of the data actually blew my mind because of the sheer irony of it. Seattle is sitting at a very comfortable 81 degrees today, and their air quality is actually improving.
They're getting a nice break.
They are breathing easy. But why? Because westerly winds are pushing the surface-level smoke away from the I-5 corridor.
Right, pushing it east.
Seattle gets fresh air today, but it feels almost like a zero-sum game because they are getting that clean air at the direct expense of cities hundreds of miles away.
Well, the wind doesn't make the particulate matter vanish. It just sweeps it off one porch and onto somebody else's.
Right. That smoke is traveling east on shifting winds, and it is actively deteriorating the air quality across Idaho, Montana, and Wyoming.
The sky just turns hazy and orange.
Billings, Montana is at 98 degrees today with rapidly increasing smoke, and it doesn't stop at the Rockies.
Oh, it goes right over them.
The smoke is traveling all the way to the Midwest. Fargo, North Dakota is at 82 degrees, and Sioux Falls is at 83 degrees, and they are both dealing with elevated wildfire smoke today.
From Washington State.
Yes. Now, the NWS did note it's elevated high enough in the atmosphere to avoid the widespread surface impacts we saw back in July.
Which is a small mercy, but it's still casting a shadow.
It's still there, casting a haze and blocking out the sun.
Yeah.
Now, how does a plume of smoke travel from a forest in Washington State all the way to a farm in North Dakota without just dissipating and scattering into the sky?
This raises a really important question about how our atmosphere is layered. We often think of wind purely in terms of surface weather.
Like what we feel on our face when we step outside.
Exactly. But the atmosphere features powerful upper-level wind patterns, like the jet stream, that act as massive, high-speed laminar conveyor belts.
Okay.
When a wildfire is intense enough, like the old Trails fire, the immense heat from the flames creates its own weather.
It literally creates weather.
Yes. The updrafts are so strong, it pushes the smoke column thousands of feet up, injecting it high into the troposphere.
Oh, wow. So it punches right through the lower atmosphere.
Exactly. It breaks through. And once that dense particulate matter reaches that altitude, it gets caught in those upper-level westerlies.
It's conveyor belts.
Right. Up there, the air is moving incredibly fast and in a highly directional stream, which allows the smoke to travel thousands of miles remarkably intact.
It just hitches a ride.
It is hitching a ride on the exact same planetary wind currents that dictate airline flight times.
And that connects perfectly back to how we started this entire conversation today.
It really does. Think back to that shortwave energy we discussed in the very first segment.
The wave pushing offshore from New York and Boston?
Exactly that one. The upper-level winds carrying the smoke over the Dakotas right now are part of the exact same continuous river of air that is pushing that shortwave energy out into the Atlantic.
So it's all one giant stream.
It is one continuous flow, and the Midwest is actually sitting in a brief lull today because of this specific flow.
Right. Chicago is mostly sunny and mostly dry at 82 degrees.
But just to their west, following that conveyor belt, Minneapolis is at 80 degrees, and they are seeing clouds build rapidly ahead of an active storm setup expected by Tuesday and Wednesday.
It never stops. The shortwave pushes east, the high pressure builds behind it, the heat dome bakes the fuel, the fire sends smoke into the troposphere, and the upper-level winds carry it right over the dome.
The atmosphere is in constant sweeping motion.
So what does this all mean? When we look at this massive data set from August 10th, 2026, we see a totally unified story.
A single, interconnected system.
We started in the muggy, oppressive humidity of the East Coast, where the air is physically too saturated for the human body to cool itself.
Right, the evaporation stall.
We watched how that pattern forces a scorching, relentless heat dome in the Southwest, where the lack of an overnight recovery window pushes concrete, power grids, and human biology to the breaking
A
point.
complete system stress test.
We looked at a staggering 45-degree microclimate split in California, caused by high pressure pinning a marine layer against the coast.
Nature failing to equalize.
And we followed atmospheric rivers of smoke from devastating fires in Washington state all the way across the high plains to the Dakotas.
Which really proves, beyond a shadow of a doubt, that weather is never just a local event.
It never is.
It is a shared continental experience. The high-pressure ridge off the Atlantic coast is directly dictating the timing of a thunderstorm over a theme park in Orlando.
Everything is linked.
The temperature in San Francisco is intrinsically linked to the extreme heat baking Fresno. Every single data point on this map is reacting to and being shaped by the data points around it.
It's just a giant web.
It is. So I would encourage you, as you are listening to this deep dive right now, to just look outside your own window, feel the breeze or look at the cloud cover, and ask yourself, what distant high-pressure system, what far-off ocean current, or what shifting jet stream is actually responsible for the weather you are experiencing in this exact moment?
It really changes how you look at the sky, doesn't it?
It absolutely does.
And I want to leave you with one final thought to mull over today, something we haven't touched on yet, but that stems directly from this data.
Oh, what's that?
Well, we started this deep dive talking about that modern reflex checking the weather app for our own zip code to figure out our day.
Right, the isolated view.
But if the atmosphere is this deeply interconnected, think about what that means for our economy, and specifically your wallet.
Oh, that's an interesting angle.
Insurance algorithms are already analyzing this exact macro-level data. If a massive heat dome in the west consistently dictates a stationary storm track in the east, at what point do insurance companies start dropping coverage for a neighborhood in Florida because of a 15-year weather pattern that is physically anchored over Nevada?
Wow. That's a chilling thought.
The atmosphere is entirely connected, which means very soon your local property value or your insurance premium might depend entirely on the atmospheric physics happening 3 states away. Think about that the next time you pull up your app.